Before I start the next piece in line, I'm going to take a quick look at the bill of materials here. Component list, and everything that's got a red slash mark next to it is complete, and I can tell you that we are getting close. Hex nuts, that's pretty straightforward. Piston ring, that's commercial. Packing, that's commercial. The valve rod is just threaded on either end and bent. Piston rod, basically the same. Inboard head, I think I'll do the inboard head today because that sounds like a lot of fun, and I'm going to do it without crazy glue. Packing gland, casting, huh? Oh, yeah, I don't know what that is. That's another one of those little 2-hole, 3-hole looking things. And a crankshaft. I'm going to save that one till last. No specific reason, just because that just seems like a good way to end this project. This is what the inboard head looks like when you start with it. Rough cast, gate on either side, and it is much thicker. It's very deceiving how big this casting is compared to what they expect you to end up with. First thing I'm going to do is I'm going to sand down the edges. I'm going to put it on my belt sander and run it around. And I'm going to try to keep it as round as I can. It's going to go to the 3-jaw. We're going to put the back features on first, cut it down a little thinner than it is. Then the rest is going to be pressure turned and clamped in a milling machine. So I think that's probably what we're headed for. First stop, belt sander. Get all the ugly off. Try to keep it as round as possible. And I'm going to measure it with a set of calipers off screen. And it has to fit nicely on the end of this guy right here. And you can see that there is plenty of extra meat on there to accomplish that. Alright, sander, here we come. Okay, I'm very close to the edge. I'm pleased with that. This is going to be good enough to squeeze in the 3-jaw. That is how I'm going to start this piece. Make sure the back is flat. Leave it hang out a little bit. Do the steps on the front. Then we're going to pressure turn it. Actually, from this side. Lathe time. First step in the process, I'm going to use the tailstock to align the inboard head. And I am going to turn the exposed bung on the end of the part to 500, something I can hold in a collet. I think a collet is going to be a very strong approach on this part, and with the excess material, why not? This feature will ultimately be turned down to fit the through hole in the base casting. And for now, we're just going to make a tooling diameter out of it and then change this over to a collet setup. Let's do it. If you decide to use this approach, cut this to whatever size you'll feel comfortable using. I am at 498.5. I'm going to clean up the face and call it right there. I will not put the through hole in until this is turned. I want the through hole and this diameter to be concentric for sake of function. So we're going to hold off on that for now. Half-inch collet is in the machine. Let's put the part in here. When you're seating a part that does not have a very long nose on it, stick it in, draw the collet closed gently and slowly, rock the part, Move it around a little bit until it finds its happy place and lock it down. This part ends up so thin that the entire part could be contained in just this flange. So the material they give you to hold on to is probably very specific. I'm going to take it down to, actually I'm not going to take it down at all. I'm going to take it down to the point where I can face it off, put the 1-inch locator boss on there, and maybe I'll clean this up to the size of the base casting radius. We'll see. Let's do it. I will be driving these by hand initially, the feeds. And for the finish pass, I noticed in the early operation when I faced the other side that it cuts better in the draw. So I'm going to reverse the direction of feed, and that'll be the only power operation on this. There you go. That was a 2/1000 of an inch deep draw pass. I'm going for a 999 -2 step on this 031 deep. So that's not very big. Let's do it. The step that you're turning on now must fit in the cylinder. Very important. It also should be concentric to the hole. They both kind of go hand in hand, so it's got to be, this hole has got to be concentric not only with the boss you turn on here, but with the other side. Any binding of the rod at operation, you're just going to have to make this hole bigger and take up the slack with the packing. Moment of truth. Beauty. I think you can probably see the step on there. And just because I'm a stickler for details, gotta clean it up. Just can't let that go. Since I'm going to pressure turn the remaining parts of this particular job here, I think it's important to have a surface to indicate, to know where this diameter is running. That's why I dusted the outside. That being said, now that I have a diameter I can trust, that I can indicate, I am going to put that hole in to confirm that the hole runs true to this. When I turn the mating boss on the opposite side, I will make sure that this is running true with an indicator assuring the concentricity. Deburr it, drill it. Spec on this particular hole is 188, and the material that they give you for the rod that passes through is also 188. I'm going to size this hole such that a 189 pin floats through the hole. I have to have at least the 1,000th clearance in here just because of the way the assembly has. You just can't have everything rock solid line contact, or it's not going to run, or it's going to wear or bind. So I'm going to give myself 1/1000th to 1/1000th, maybe 2 clearance on this hole. I believe the packing will take care of any gaps. Man, how is that for close? Holy mackerel. That's a close one. I do actually have a boring bar that will fit in there comfortably, but I just don't feel like setting it up. And I have about 10/1000ths to go, so I'm good. Shoot for 8, try the gauge. All right, deburr it, flip it around. And anybody that's noticed that this isn't going in very deep, the lead on this particular boring bar is probably almost twice as long as the actual finished part. So that bore went plenty deep to finish this part. Back to the 3-jaw. I could probably grip this on a 1-inch collet, but I'm just not comfortable doing that. Not gonna, I'd rather pressure turn it. Let's do it. 3-jaw chuck is set up. This is the sacrificial 303 blank from before when I did the cylinder head. I'm gonna put a 1-inch diameter, very superficial counterbore in this so that when I press the inboard head against this, it doesn't act like a cymbal and distort the center of the part. I want the center of the inboard head to rest on the bottom of the pocket. That's really important to not crush the piece. Let's do it. Beauty. Minimal movement, but there is movement. And yes, if you wanted to, you could drill and ream a hole in here, put a pin in it, and locate it from the pin in the ID. Sure, there's a dozen different ways to do this. I'm going to use the live center and the bull nose that I used for the opening gland in this build. Go from there. This is a dimensional check. Once you have surfaces you can trust, break down the setup, check it thickness-wise, make your adjustments to your DROs or your travel dials or your table stops, your carriage stops, and go from there. I'm looking for an 062 thick flange right there. And that is probably about 3 times thicker than it needs to be, so let's see what we got. 062 is the number. Make sure you zero your digital before you take the part out. Looks like 99 more ought to do it. Going to go to 98 and a half just because. I have 3/1000ths remaining on this face to come off. When I turn this diameter down to its finished spec, I will draw face this off to the final thickness. This is where you want to establish your concentricity just before you get this to run, just before you turn this to the final size. Make sure the OD of this thing is running true. Double check the concentricity before the finish pass. There you go. I will take that all day long. Close enough. Let's finish up the 310 diameter and the face, move to the mill. Okay, now for anybody wondering how I'm going to turn the face of this thing down to the required spec, I'm not. I'm going to strap this down to a fixture plate in the mill to do the hole pattern, and I'm going to mill that to height. So just because it looks like a round feature, it doesn't need to be done in a round machine. So that's how that's going to be done. Strap it down the same way I did the head. Drill the 6-hole pattern, put an end mill in, and deck this off to the finished height. Let's see if it fits the base. That'd be a plus. That is where that piece fits, right there. This will be considerably shorter, and this will be the receiving end for the Teflon packing that goes around the piston rod that'll go in and out of that hole. And if you want to see how your concentricity looks, now's the time you're going to get a pretty good idea how you laid it out. I would say that's a win. That is pretty. I'm looking down here right now. I like it. All right, let's strap it down, put some holes in it. We are back in the mill to put the 6-hole pattern in this plate and take that center boss down to the specified dimension on the print. And once you get this thing all dialed in and running true, I'm going to put a 140 end mill, 9/64 end mill in the collet, and I'm going to plunge these holes just for no other reason than just because I like the way end mills plunge cut on this material. Give me a nice clean hole. It is strapped down. I am indicated 0 on the stem, and the stem does end up being very superficial to that large surface. So if you're thinking about holding on to that for any particular reason, it may not end well. I think this is a safer option. All right, let's plunge some holes in this thing and finish it up. You're going to end up using this bolt pattern a lot, so if you have notes on what the spacing is, keep them handy. You can use it a half a dozen times. You can use it for the cylinder head, the inboard head, the end of the frame, and both ends of the cylinder itself. I'm going to set the depth of the cutter to go just below the surface of the aluminum that the part is sitting on, and that should be sufficient. Alright, this gives me a very good opportunity to demonstrate exactly what could happen, did happen, and sometimes you'll feel it, sometimes it'll cause you to blow up a cutter. When you plunge an end mill like this, it is very possible that you're going to create a very small disc that will be underneath the cutter. Let's see if I can find mine. There we go. Right here. Alright, I'm going to put that right there and refocus this camera on that. A very small remnant, just like this little piece right here. You can see it right between my fingers. That will proceed in front of the end mill as the end mill cuts through the part. Now, when that happens, this is going to stick to the bottom of your end mill. It's going to spin, and you're going to think, well, gee, the end mill's not cutting anymore. You're going to apply more pressure, and something's got to give. So be very aware that if you're using a plunge cut end mill to do an operation like this, when the pressure starts to get a little bit great, back the end mill out, blow out the hole, and I'll bet you have one of these little miniature pennies sticking in the bottom of the hole. It happens a lot, so beware. Let's put a little bit bigger cutter in there and reduce the height of the center boss. The height on this boss is 0.62, about 1.5 millimeters. Setting the stop on my quill. Pulling down to the stop, and I'm going to bring the table up to a specified shim thickness. That is a 10 thou shim. That's about 0.25 millimeters. If you use this technique, do not put the shim under the cutter as you're going down or up with the table. You risk cracking the corners off the cutter. You don't want to do that. There you go. Nice little drag, and away you go. Drop the table to accommodate the height of the boss and zero out the dial. Drop the table another 10 to allow for a finished pass. Start chipping away at it. Alright, that'll do it. Let's take it out, clean it up, take a look. This is what the final product will look like. And I'll tell you, there's a couple of different ways you can do that, and I think pressure turning is probably the way to go. I am not a fan of crazy glue for a part with this kind of mass. You know, if you're working on smaller stuff, lighter stuff, really super thin stuff, well then by all means have at it. But for something like this, just not a fan of crazy glue. And to be honest with you, 100% honest with you, I have never used crazy glue in any setup I've ever done in all the years I've been doing this. Not saying it doesn't have its place, I just never warmed up to it. So this piece is incredibly thin. It's 0.156 thick. This boss is just as high as this flange is thick, and this guy here is the locator for the cylinder and the cylinder gasket. Flip over to the casting, is this sitting right here. All goes well. The locator diameter will fit inside of that. And to everybody that's going, hang on a second, yes, this section right here is a receiver surface for the packing that will be installed from this side. So to anyone that says, gee, it's a drill point is required or a chamfer is required, well, we're going to find out, because I'm going to leave that flat because it's flat on the print. And if you'll recall, the end of the cylinder feature that I did here is also flat. This assembles as such. And when you assemble the cylinder to this, depending on where you lined everything up, what your casting looks like, how you cut it, whether or not you decided to use dimensions or just eyeball it, this section right here, where are we at? Right there, may be proud and may encounter the cylinder when you put the cylinder on there. Right, wrong, indifferent, whether you hit the numbers or not, it is very possible that you will have an interference there. It is incredibly close and nearly impossible to get on film. Right there, you can see it. That area is remarkably close. So if you do have any type of leaking going on, do yourself a favor and knock this tip off right here. It doesn't have to go all the way flush to the surface. It just has to be thinner than this thickness right here, so it is subsurface. Knock it down with a file, knock it down with an end mill, do what you got to do, but be aware if the cylinder sits cocked, that is the reason it's going to do it. Alright, that's all we got this time around. Hope you like the technique. It is a really solid technique for holding thin parts, and worked out well on this one for sure. Once again, thanks for watching. Stay well. Joe Pye, Advanced Innovations in Austin, Texas. I'm out.